Good morning, students. Good morning, Akash. Good morning, Sneha. Good morning. Good morning. Good morning. Good morning, everybody. Okay, let us start with the lecture today. So this is your calculus revision lecture for JEE Mains. Let us start with the revision over here. And these are some of the very most important questions for your upcoming JEE Mains. Fine. So let us begin with this. So the first question, you have fx is tan pi x by 2. X is less than 1, x minus 1 when x lies between 1 and 2, and when x is greater than 2, we have 1 upon 2 minus x. So now you all can observe this options. These options are mainly based on continuity and the discontinuity. So basically we are just going to check the continuity at x equals to 1 and x equals to 2. Okay. And this is comparatively a much more easier question. Okay. We start with a very basic question at the very beginning. Good morning. Good morning. Okay. So this is our function fx is tan pi x by 2 when x is less than 1. Now carefully observe this function. What happens whenever you're going to check the continuity at x equals to 1 and x equals to 2, by just mere observations you can simply just conclude that this is continuous or discontinuous. Okay, so in this case observation is very important. Carefully just observe when you're going to check for the continuity at x equals to 1. When you're going to check the continuity at x equals to 1, you are going to find the left hand limit and the right hand limit, right? Just very basic definition I'm saying. So whenever you're going to check the continuity at left hand limit and the right hand limit, if you observe on the left hand limit at x equals to 1, suppose on the left hand limit we have whenever you're going to consider x tends to 1 minus, which means you're going to consider this branch tan pi x by 2, this branch, and the thing is this is tan pi x by 2, and this will become undefined gradually if you put x tends to 1 minus, because suppose if you think like this, that suppose if we are asked to find the left hand limit of this, limit x tends to 1 minus fx, obviously which branch we are going to consider? This branch, tan pi x by 2. So what we do is, or more generally what we can do is, we can write this as limit h tends to 0 f of 1 minus h. So this is limit h tends to 0 f of 1 minus h. So this is basically tan of pi into 1 minus h divided by 2. And when h tends to 0, this tends to 0, this tends to 0. So we have tan pi by 2. So which is now this is pi by 2 what? So this is pi by 2 minus. More specifically, if you see, this is pi by 2 minus. We could have directly put this limit as well, but if you just use this definition that limit x tends to 1 minus is limit h tends to 0 f of 1 minus h, so this makes this a more clear. So this thing is basically tan pi by 2, tan of pi by 2 minus. This is tan of pi by 2 minus. Okay, and this is what? This is undefined. This is not defined. Tan pi by 2 minus. If you visualize the graph, all of you have done the graph of tan x, right? So this is the graph of tan x, and at pi by 2 tan is undefined. Suppose if I just draw a dotted line over here, so you have the graph of tan x like this, and this goes to plus infinity. So tan pi by 2 minus means, which means you're approaching pi by 2 from the left hand side, it's pi by 2 minus, and pi by 2 minus here tan, so in this case this tends to plus infinity. So this is infinity, which means this is not defined. So what you're going to write is this is not defined. This is not defined. So basically this is not defined at x is equals to 1. So no need to check the right hand limit now. In case you want to check, you can check, but still this is no need to check the right hand limit, because obviously the limit does not exist at the the left hand limit only does not exist. So this is not defined only. Right, so obviously this is discontinuous at x equals to 1. Okay, so this has to be discontinuous at x equals to 1. Now regarding x equals to 2, if you check the continuity at x equals to 2 directly from here, that limit x tends to 2 plus, suppose the right hand limit at x equals to 2. Similarly, if you consider the right hand limit, which means you are going to consider this branch 1 upon 2 minus x, this branch, which means limit x tends to 2 plus fx. I'm going to check the right hand limit at x equals to 2. In this case, if you observe, limit x tends to 2 plus 1 upon 2 minus x. So this is this branch, we are going to consider this branch. So this is when x tends to 2 plus, this tends to positive infinity. Once again, this is not defined. Obviously, in this case also the limit will not exist. In case you want to find the right hand limit, you can find it for your practice, but this can be a direct solution in this manner. So the thing is, this is continuous, discontinuous. F is discontinuous both at x equals to 1 and x equals to 2. This is the option D is the right answer in this case. Okay. So you can check the right hand limit in case you want to check the right hand limit at, suppose in case if you say that I want to check the right hand limit at x equals to 1. So which means limit x tends to 1 plus. 1 plus means which branch? This branch we are going to consider, x minus 1. So 1 plus fx is limit x tends to 1 plus x minus 1, and this tends to 0. This tends to 0. Obviously, you can see that the limit does not exist for the, it's not defined only at, it's unbounded. The limit is unbounded for the left hand limit at x equals to 1. And in case of right hand limit, it is 0. Obviously, limit does not exist in this case. And it is discontinuous both at x equals to 1 and x equals to 2. Okay. Once again, in case you want to see the graph of this function, that also you can just draw. All of you have done graph sketching. Easily you can draw the graph of this function. The graph is this is a very basic graph. For each intervals, you have to consider the graph, which means for each intervals means for x less than 1, or let's say for in between, what happens, what is the nature of the graph? The graph is linear function. We have a linear function in between 1 and 2, the interval close interval 1 and 2. When x belongs to 1 and 2, we have a linear function x minus 1. Okay, so it will be a straight line in that case, right? So you can draw the graph in that case. Okay, so let us move on to the next question. Limit n tends to infinity, 2 to the power n plus 1 plus 3 to the power n plus 1 divided by 2 to the power n plus 3 to the power n. This is once again a very basic question. If you see, comparatively a much more easier question. So let's see how to just solve this thing. So first of all, if you observe this limit, carefully observe in this case. Observation is very important for the questions of JEE. Or for any examinations, I am saying observation is very important. If you carefully observe, so how to just solve this limit? Limit n tends to infinity, 2 to the power n plus 1 plus 3 to the power n plus 1 divided by 2 to the power n plus 3 to the power n. So we have limit n tends to infinity. What we do is we'll take 3 to the power n plus 1 common. So this becomes 2 by 3 whole to the power n plus 1 plus 1 divided by. Okay, now obviously we are taking 3 to the power n plus 1 common both from numerator and the denominator. So this is 2 by 3 whole to the power n into 1 by 3, because you are taking out 3 to the power n plus 1 common. We are taking out 3 to the power n plus 1 common from both the numerator and the denominator. So this is 2 to the power 2 by 3 to the power n into 1 by 3, and this is plus 1 by 3. right? Now, what was the reason for this thing? What was the reason for us to just break this into this format, this 2 by 3 whole to the power n, 2 by 3 whole to the power n format? We can write this, you can write this more generally as this to be 2 by 3 whole to the power n multiplied by 2 by 3. This is also fine. But the thing is, what was the purpose? What was the purpose for us to just break this into this format? If you observe over here, 2 by 3 whole to the power n, and we have limit n tends to infinity. This is a proper fraction lying between 0 and 1. It's a proper fraction which is lying between 0 and 1. So 2 by 3 whole to the power n, I have said this, you have a proper fraction, and when limit n tends to infinity, proper fraction whole to the power n is what? This tends to 0. This will tend to 0. So which means this thing tends to 0, this thing tends to 0. So we have 1 upon 1 by 3. So answer is 1 upon 1 by 3, which is 3. That's all. As I have said before that this proper fraction whole to the power n, and you have n tends to infinity. This thing is very important for questions of JEE. Lots of questions, I have seen lots of questions based on this format. That proper fraction whole to the power n when n tends to infinity. This tends to 0. Based on this, we have done lots of questions, so this concept must be very clear to you. Okay, let us move on to the next question. So once again, a limit question. Limit x tends to 0, cos x whole to the power 1 upon sine square x. Now this limit, we have solved these type of limits quite a few times. This is cos x whole to the power 1 upon sine square x. And this is, now don't expect easy questions more than this. Okay, these are very easy questions. And all of you should get full marks in this question. So the thing is, limit x tends to 0. Limit x tends to 0, cos x whole to the power 1 upon sine square x. So obviously there are two methods of solving this question. I have told you there are two methods of solving this question. Obviously, one, you directly apply the theorem which I have said whenever you have the form 1 to the power infinity. Obviously, you can see that this is of the form indeterminate form, which is 1 to the power infinity. When x tends to 0, cos x tends to 1. So this is 1 to the power. When x tends to 0, this tends to 0, which means 1 upon 0 tends to infinity. So this is of the form 1 to the power infinity. Indeterminate form, which is 1 to the power infinity. So whenever you see this form, you have two theorems, which I have said in my class that there are two theorems you are going to apply directly. If you know the result, then you will directly get the formula. So, but in this case, so obviously you will have two methods. First, you directly apply the theorem which you have done in the class, or you take log on both sides in case if you have forgot the formula. In case you forgot the formula, just simply apply log on both sides and then try to solve. Okay. But in case you remember the theorem or the formula, so it is better to just solve this directly. Okay. So I'm going to use the theorem process, which is the method which we have done in the class. So we have a limit x tends to 0, cos x whole to the power 1 upon sine square x. Now in this case, understand this carefully. This is 1 to the power infinity form. So cos x tends to 1, and this 1 upon sine square x tends to infinity when x tends to 0. So in this case, if you carefully observe, so first identify what is fx and gx. So this is your fx, right? And this is your gx. This is your gx, fx to the power gx. In that case, what? And the condition was what? The condition was limit x tends to 0, fx should be 1, and limit x tends to 0, g of x should be infinity, and that is what we are having. So the second rule, which I have said in my class, the second rule should be applied in this case. So e to the power, so this is directly e to the power limit x tends to 0 f of x minus 1 into g of x. This was the formula. In case you have, so if these conditions are satisfied, then you have the formula e to the power limit x tends to 0 fx minus 1 into gx, and this is applicable only if the form is 1 to the power infinity, if the indeterminate form is 1 to the power infinity. So in this case, what we do is e to the power limit x tends to 0, limit x tends to 0. Now fx in this case is cos x minus 1 into gx. Gx is what? Gx is 1 upon sine square x. So this is e to the power limit x tends to 0 cos x minus 1 upon sine square x. And we just now simply need to evaluate this limit which is in the powers of e. We just simply need to evaluate this limit. So how do we just solve this limit? There are lots of methods, like you can one method is you can simplify this cos x minus 1, which is minus 2 sine square x by 2, right? Then you can adjust this half and all, right, by taking one it's basically minus 2 sine square x by 2, so that 2 can be adjusted, try to bring into the form of some standard limits, sine x by 2 upon x by 2 or sine x by x format, right? And we have done this limit quite a few times in the class itself. This is a very basic limit. Okay, without the L'Hopital's rule you can solve this. Just try to bring this into some format of limits. So which is basically, this is, you will get this as e to the power minus half. E to the power minus half is the answer. Okay. Okay, so we have a very good question now. Let fx is equals to sine of box of minus x square divided by box of minus x square when x is not equals to 0, and alpha when x is equals to 0. Here box means the greatest integer less than or equals to x. Suppose box of x means the greatest integer less than or equals to x. All of you know this one. And this is continuous at x is equals to 0. So it is already mentioned that this is continuous at x is equals to 0, which means this satisfies the continuity criteria. And we have to find the value of alpha in this case. What is the value of alpha? Okay. This is a question. So what is the value of alpha? So now it is mentioned that this function is already a continuous function at x equals to 0. It is already mentioned that this is continuous at x is equals to 0. So it is better. So we apply the definition of continuity and then simply solve this. So you know that if a function is continuous, then the left hand limit, right hand limit, and the function value at that point is equal. So which means that limit x tends to 0 plus, limit x tends to 0 plus f of x equals limit x tends to 0 minus f of x is equals to f of 0. Because this is continuous at x equals to 0, that's why we are considering the left hand limit and the right hand limit at, and the function value at x equals to 0. Now here, in this case, when x tends to 0 plus, suppose if we talk about this right hand limit x tends to 0 plus f of x, limit x tends to 0 plus f of x, which is limit x tends to 0 plus sine of minus x square divided by box of minus x square. Sine of box minus x square divided by minus of x square, greatest integer of minus of x square. Now understand this part very carefully. Just remember the very basic definition of limits and the very basic definition of greatest integer function, nothing else. This question is just based on the concepts, nothing else. Now, if you take x tends to 0 plus, when x tends to 0 plus, this x tends to 0 plus, this is basically 0 plus whole square minus of 0 plus whole square, right? 0 plus means what? Very number which is very close to 0. You're approaching 0 from the right hand side. 0 plus is 0.00001, suppose, like this. Okay, so basically what we are having is the greatest integer of minus of 0 plus whole square. Similarly, when x tends to 0 plus, this also tends to, this x tends to 0 plus, which means this is also minus of 0 plus whole square, right? The thing is, in this case, minus of 0 plus the whole square. What is the meaning of this? You have the greatest integer of minus of 0 plus whole square. So obviously, whenever you're considering 0 plus and you're taking the whole square, obviously that will remain to be a positive. But the thing is, in the front you have a negative sign. Right, in the front you have a negative sign, minus 0.0000001, like this, isn't it? So which is what? So this turns out to be sine of minus 1 divided by minus 1. Right, this becomes sine of, this is sine of minus 1 divided by minus 1, which is minus of sine 1, minus of sine minus 1, and which is finally sine of 1. This is sine of 1. Clear with this limit? Swaroop, your logic is wrong, because this is possible only when limit x tends to 0. Sine fx upon fx is 1. This is 1 when fx tends to 0, and this fx also tends to 0 when x tends to 0. Right? Clear with this, Swaroop? Okay, let us move on to the next. Okay, let us move on to this left-hand limit. Limit x tends to 0 minus fx, which is limit x tends to 0 minus sine box of minus x square divided by box of minus x square. When x tends to 0 minus, now see this part, when x tends to 0 minus, this x will be, this x tends to 0 minus, we have, this is 0 minus the whole square, right, divided by, this also will become minus of 0 minus whole square. So 0 minus whole square, which should be negative, will now become positive, right, will now become positive, but there is a negative sign in the front, which will again make this to be absolutely correct, minus 1, absolutely correct. So this will be minus 1 once again. So this is sine of minus 1, same thing, sine of minus 1 divided by minus 1. Okay. Because of this negative sign in the front, this will always be minus 1 over here. So, isn't it? This will be minus 1 then. Sine of minus 1 divided by minus 1, which is once again sine of 1. So you can see that the left-hand limit equals to the right-hand limit. The limit exists in this case. Now what we can do is we can simply find out what is the value of alpha. You know that is the function value. It is equal to the function value. What is f of 0 in this case? What is f of 0? F of 0 is alpha. F of 0 is alpha. So which means by this definition, equation number 1, we have sine 1 is equals to alpha. This means alpha is equals to sine 1. Alpha is equals to sine 1. Okay. Alpha is equals to sine 1. So in this case, B is the correct option. B is correct. Okay, so we now have this question, limit n tends to infinity, 1 upon root n multiplied by 1 upon root 3 plus root 6 plus 1 upon root 6 plus root 9 and so on up to 1 upon root 3n plus root 3n plus 3. Okay. So I have told you one trick to solve these type of questions. Okay, so let's go by the trick method first. Solving this within seconds. If you want to solve this within seconds, let's go by the trick method. What is the trick in this case? The trick method. Suppose you want to go by the trick method. What is the trick method in this case? What is the trick method? See the difference. Observe the difference for each terms. It's root 3, root 6. The difference is 3. Root 6, root 9. The difference is 3. Similarly, observe in this case, this is the difference is 3n plus 3 minus 3n. The difference is 3, which means the difference is a constant, which is 3. So what was the trick in this case? Take square root. Since the difference is 3, take square root, right? Because we have square root over here, so take square root. And because this is 1 upon square root of something, so this is answer will be what? Answer will be 1 upon square root of this 3. 1 upon square root 3. Clear with this trick? We have done this in the class, right? Fine. Now, lots of questions can be possible, like just observe the difference in this case. The difference is very important. Answer will be what? Answer will be 1 upon square root of the difference. This question could have been in this manner. Suppose 1 upon square root 2 plus square root 4 plus 1 upon square root 4 plus square root 6. Okay, in that case, the difference is 2. Answer will be 1 upon square root 2. Okay, so now let us solve this formally. Resolve this formally. So there are lots of ways to solve this question. So I'll use one standard method to solve this question. So first we have limit n tends to infinity, 1 upon root n. Let us try to represent this in terms of summation, which is summation r is equals to 1 to n. 1 upon this is root 3r plus root over of 3r plus 3. In terms of summation, we can represent this entire sum in this manner. So from this we have limit n tends to infinity, 1 upon root n, summation r is equals to 1 to n. Now here what we do is we multiply with an extra root n in the denominator itself. So this becomes root n into square root 3r by n plus square root of 3r by n plus 3 by n. So why we are just multiplying this? The reason is this 1 by root n and this 1 by root n over here. If you multiply this, this becomes 1 by n, and we know that our standard form of limit, this standard form you must have done in your classes, that limit n tends to infinity, summation r is equals to 1 to n, 1 by n f of r by n is integration 0 to 1 f of x dx. We are simply replacing this r by n by x, right? So we have done this limit. So basically, so this turns out to be limit n tends to infinity, summation r is equals to 1 to n. You can take this 1 by root n inside the summation because the summation is dependent on r, right? So this is basically 1 by n, this becomes 1 by n multiplied by 1 upon, this is 1 upon root 3r by n plus root over of 3r by n plus 3 by n. So this is of the form r by n. So basically this is now what we can do is, this is straightly we can write this as integration 0 to 1 1 upon root 3x plus root 3x, obviously. And once again, now some students often do get confused over here that if n tends to infinity, now we have one 3 by n over here. So how to deal with this 3 by n in this case? Now as n tends to infinity, you just simply take this n tends to infinity, so this 3 by n tends to 0. Obviously make this 0 and then simply solve this. So this is integration 0 to 1, 1 upon root 3x plus root 3x. Okay. Now this is one basic integration. So this is 1 upon 2 root 3 into integral 0 to 1, 1 upon root x dx. So this is 1 upon 2 root 3 multiplied by 2 root x. Range goes from 0 to 1. So this is 1 upon root 2 root 3 multiplied by 2, which is 1 upon root 3. Okay, let us move on to the next question. F such that R to R be a differentiable function such that f of 2 is 2. And this expression is given mod of fx minus fy less than or equals to 5 into mod of x minus y whole to the power 3 by 2. Right? For all x belongs to R. I have told you this is one of the favorite expressions of NTA. You will get questions based on this expression in almost in every year. You would get these type of questions in which you involve these type of expression fx, these type of expressions. I have said this in my class, right? These type of expressions fx minus fy and less than equals to mod of x minus y. These type of expressions are very common expressions. You can expect at least one question every year in your paper, in your JEE mains paper. So this is mod of fx minus fy less than or equals to 5 into mod of x minus y whole to the power 3 by 2. For all x belongs to R. This is given. And for y belongs to R. And gx is also defined to be x cube into fx. You're asked to find what is g prime 2. What is g prime 2? So first, let us deal with this function. Very common expression, and we have already done this quite a few times in our class. It's less than or equals to 5 into mod of x minus y whole to the power 3 by 2. So this is how to solve this. First, bring one x minus y over here in the denominator on the left hand side and make this whole to the power half. Make the right hand side whole to the power half. Now take limit y tends to x on both sides. Why should we take this? Just now you will see why are we just taking this. Less than or equals to, this is limit y tends to x mod of x minus y whole to the power 1 by 2. Just now you will see why we are considering this. Now limit y tends to x and fx minus fy divided by x minus y. Obviously this is f prime x. This means f prime x mod of f prime x less than or equals to 5 into limit x y tends to x. This becomes 0. When limit y tends to x, this becomes 0. So this is ultimately 0. So what we have is mod of f prime x less than or equals to 0, which means you know that this is a negative. This cannot be, mod function cannot be negative quantity. So obviously this means f prime of x is equals to 0. Obviously mod of x, mod of something, this cannot be less than 0. This is, so the only possibility is equals to 0. So f prime of x is equals to 0. This was the main purpose, to find out this relation. Now we can apply this to find g prime 2. If you see what is g prime 2, g prime 2, what is gx first? Gx is x cube f of x. First find what is g dash x. Differentiate this. So this is x cube into f prime x plus 3x square f of x. Now you need the value of g prime 2. So you put x is equals to 2 over here. So this becomes g prime 2 equals 2q into f prime 2 plus 3 into 2 square into f of 2. Obviously, you can see that f prime of x is equals to 0, which means f prime of x is a constant function, right? Which means for any values of x, this will always give the output value 0. So which means f prime of 2 is also 0. This becomes 0. So this entire thing is 0. So you are only left with this thing. So g prime of 2 is 3 into 4 into f of 2. Now what is f of 2? F of 2 is already given. So this is into 2. So this is 12 into 2, which is 24. So option D is correct. Option D is correct in this case. Okay, so let us move on to the next question. F such that R to R is such that f of 0 is 0 and mod of d of fx divided by dx is less than or equals to x for all x. Okay, now let us move on to the next question. F such that R tends to R is such that f of 0 is 0 and mod of d of fx by dx is less than or equals to 5 for all x. Then we can conclude that f of 1 is in which one of these intervals? 4 options are there, so which one of these intervals? This is comparatively a much more easier question. Obviously, you all can observe that if you get the function, if you get the main function fx, the range of the function fx, then you are very much done. You can easily find what is f of 1, what is the range of f of 1. The thing is, to get fx, what you do is, first of all, let's apply the properties of mod function, modulus. This is d of f of x divided by dx is less than or equals to 5, which means in this case we have d of fx by dx. So this lies between d of fx by dx lies between -5 and 5. So in this case, now what you do is you integrate, and one benefit is this condition which is given f of 0 is 0. F of 0 is 0. This is one of our benefit in this case. So if you integrate, there will be a plus c, constant plus c, which can be removed by this condition f of 0 is 0, right? All of you can visualize that you have the constant c, integrating constant c, which can be removed by this condition f of 0 is equals to 0. C will be 0 in that case. You will only have 5x less than or equals to fx less than or equals to 5 into x. So this is the range of fx in this case. Now we can simply find in which interval this f of 1 lies. Obviously, f of 1, for f of 1 to lie in some interval, you simply put x is equals to 1. If you put x is equals to 1, this is -5 less than or equals to f of 1 less than or equals to 5. So option B is correct, because this means what? This means f of 1 belongs to close interval -5 to 5. Option B is correct. Let us now move on to the next question. It's a question from functions. You're asked to find the domain of this function fx, which is greatest integer x multiplied by sine of pi upon box of x plus 1. Okay. You're asked to find the domain of this function. All of you know the domain of this function, box of x. This is for all real numbers. X belongs to all real numbers. This is the domain of this function. We try to find out the domain of this sine pi upon box of x plus 1. First of all, for this domain, concentrate on what is this sine theta's part, this pi upon box of x plus 1. First of all, for the domain, you should have the condition box of x plus 1 not equals to 0. Okay. If you consider a box of x plus 1 is equals to 0, in case if you consider this, you will have in case if you consider box of x plus 1 is equals to 0, by property you have x plus 1 should lie between 0 and open interval 1, which means if you subtract 1 from here, you will get minus 1 less than or equals to x less than 1 minus 1, which is 0. X should lie between minus 1 and 1, which means initially you have to consider a box of x plus 1 is not equals to 0, which means you have to exclude these points, which means what is the domain of this function? The domain of this function, which means the domain of sine pi upon box of x plus 1. So the domain in this case is all real numbers except these points, which is close interval minus 1 and open interval 0. Okay, this is the domain of this function. Now what we are going to do is we are going to take the intersection of these two domains, which means finally the domain of f. What is the domain of f in this case? The intersection of x belongs to R, intersection R minus close interval minus 1 and 0. Obviously, if you see the intersection part over here, so this is x belongs to R and R minus close interval minus 1 and 0. If you see the intersection part is x belongs to, in this case, finally the domain is minus infinity to minus 1 open interval, because this is not defined at x is equals to minus 1. Function will not be defined at x is equals to minus 1. Union close interval 0 to infinity. We include 0 in this case as the greatest integer of this function. This greatest integer of this function, box of 0, is 0, and 0 multiplied by some oscillating function. Sine of something is oscillating function. It's just any value in between minus 1 and 1. Obviously, so this is 0 multiplied by some finite number in between minus 1 and 1 is 0 only, so we include 0 in this case. So this is the domain of this function. Now there can be some possible questions that there can be some more possible questions from this part, that find the points of discontinuity of this function f in its domain. You're asked to find the points of discontinuity in its domain. If you see that there are some options will be given, minus 1, 0, 1. Okay, like this, some options will be given, and these are some cases which you are going to analyze. Or suppose this can be in this manner, like the options can be in this manner, that this is continuous for, or let's say not continuous. This is discontinuous for integer points. This is continuous for integer points, right? So as we have done this function, you must have seen when we have discussed the continuity of this function, we have discussed 3 cases. One is for all integers, right? The left continuity of the function at x is equals to minus 1, and the right continuity of this function at x is equals to 0. And 0 was the only exceptional case, which means 0 was the only exceptional case in which the function was right continuous. Right continuous because to the left of 0 the function is not defined. The interval starts from 0 only. To the left of 0 it is not defined. Similarly, to the right of minus 1, over here to the right of minus 1, function is not defined, so you check the left continuity. Okay, in this case, if this is continuous at 0, we call this as right continuous at x equals to 0. You don't check the left hand limit in that case, you simply check the right hand limit and the function value at x equals to 0, because this function is defined from, it starts from 0 only. So in case you are going to check the continuity of at 0, you are going to check the right continuity. Okay, so this can be one possible question, that find the points of discontinuity of this function in its domain. Okay, so you first need to find what is the domain, and then you need to find the points of discontinuity. Okay, let us move on to the next question. Evaluate the integration x into pi plus 49 whole to the power 15 upon 7 divided by pi square x to the power pi plus 7 dx. Okay. It asks to evaluate this integral. You're asked to evaluate this integral. So let's see how to just evaluate this. So first of all, if you carefully observe, now I'm not giving the options. There might be some options given in your, obviously some options must be given. But let's see, first focus on how to solve this question. So first of all, we have the integration to be x into pi plus 49 whole to the power 15 by 7 divided by pi square x to the power pi plus 7 dx. Now carefully observe over here. If you consider the substitution x to the power pi plus 7 is equals to t, this becomes pi into x to the power pi minus 1 dx is dt. And if you just rewrite the value of this pi as 22 by 7, so 22 by 7 minus 1 is 15 by 7, so which is x to the power 15 by 7 dx is dt upon pi. So this is basically integration. If you rewrite this as x to the power 15 by 7 into pi plus 49 whole to the power 15 by 7 divided by, this is pi square into x to the power pi plus 7. And this part, carefully observe, this part is a constant. This is an entire constant. Okay. So this is pi plus 49 whole to the power 15 by 7 divided by pi square, and we have integration. Now x to the power 15 by 7 dx is dt by pi. Okay. So this is dt by pi, and this is 1 upon x to the power pi plus 7 is 1 upon t. X to the power pi plus 7 is t. That's what we have considered. The substitution we have considered. It's just a pure play of substitution. It's just a pure play of substitution, nothing else. So this is pi plus 49 whole to the power 15 by 7 divided by pi cube. Integration 1 upon t, which is log t plus c. So this is pi plus 49 whole to the power 15 by 7 divided by pi cube log of, replace the value of t. T is x to the power pi plus 7 plus c. This is our answer. Such a simple problem. This looks like a dangerous one, but obviously just a pure play of substitution. Now this depends upon your practice. The more practice you'll do, you learn the substitution, more substitutions, right? Indefinite integrals, most of the sums in JEE Mains are mostly based on either substitution or integration by parts. Okay, let us move on to the next question. This is evaluate this integral minus 1 to 1 x cube plus mod x plus 1 divided by x square plus 2 mod x plus 1. Okay. So we have to evaluate this integral. Now how do we just solve this? First, what we do is, in this case, first let's divide this into two parts. Let's divide this integral into two parts. One is this part, integration minus 1 to 1 x cube upon x square plus 2 mod x plus 1 dx. Another part is integration minus 1 to 1 mod x plus 1 divided by x square plus 2 mod x plus 1 dx. Okay. So now we have two functions. We have two functions, this one and this one. We are going to analyze these two functions now. Fx is x cube upon x square plus 2 mod x plus 1, and we have gx, one more function gx is mod x plus 1 divided by x square plus 2 mod x plus 1. Okay. So first of all, the first property will come to your mind is the odd even property, right? Odd and even property. If since you have the range integration goes from -1 to 1, minus a to a, obviously the odd and even property will come to your mind. So let's check whether these two functions are odd functions or even functions. Okay, so this is, if you check for this function, suppose f of minus x, this is minus of x cube divided by, this is minus x square plus 2 into mod of minus x plus 1, and this is minus of x cube divided by, this is x square plus 2 into mod x plus 1, which is minus of f of x, which means f of minus x is equals to minus of f of x. This means an odd function. Fx is an odd function, which means integration, this integration will be equals to 0. So now let us analyze this gx. Gx is what? What is gx? Similarly, check for the odd even criteria. So let's check for what is f of g of minus x. This is minus of mod of minus of x plus 1 divided by x square minus of x square plus 2 into mod of minus x plus 1. So this is basically mod of minus x is x mod of x plus 1 divided by, this is x square plus 2 mod x plus 1, which is equals to gx only. So which means we are having g of x is equals to g of minus x, which basically means we are having g of minus x is equals to g of x, isn't it? Which means this is an even function. This is an even function. And what was the criteria for even function? Just we are now only concerned about this integral. So what was the criteria for even function? This was, if gx is an even function, then this is integration -1 to 1 mod of x plus 1 divided by x square plus 2 mod x plus 1 is basically 2 into integration 0 to 1 mod of x plus 1 divided by x square plus 2 mod x plus 1. Range goes from 0 to 1. No need to take this mod sign now. This is always positive. So 2 into integration 0 to 1 x plus 1 divided by x square plus 2x plus 1. Okay. Obviously, this is a very basic substitution. If you take this to be t, you will get 2x plus 2. Obviously, we have a 2 multiplied over here, so this is directly 2 into log of mod x plus 1, and integration goes from 0 to 1. Okay, and you can just simply put the values over here. Just simply put the values. So 2 into this is 2 into 1 plus 1. So log 1 plus 1. So which is log 2. So which is log 2 minus log 1. So 2 into log 2. So 2 into log 2 minus log 1. Log 1 is 0. So we have 2 into log 2, which is log 4. Log 4 is the answer.